Okie dokie. So during the interview, you'll be looking at me, and we'll just try to have it as conversational as possible.
Okay.
The only time you're going to look at the camera is right now when you're just going to introduce yourself and tell us what class and what school we're at.
Okay. My name is Katie Penny. I teach 3rd grade at Van Gorder in Sparks, Nevada. Good.
Excellent.
Okay.
All right. Let's start right off here. We want to understand the decisions you made in planning for this lesson and how it fits into the unit and year. So how does this lesson connect to and build on students' prior skills and knowledge, what was taught before the lesson, and what will come after it?
Okay, first of all, we built the conceptual understanding of multiplication, starting with a lot of manipulatives and multiple representations and arrays and things like that, so they can have an understanding of what multiplication is. So we start with conceptual, then go to fluency, and then this was an example of an application lesson for multiplication. Before the lesson was taught, I've worked a lot on building a safe classroom environment where students are sharing and verbalizing and kind of taking risks in their sharing. We've modeled a lot of sharing when you don't understand the concept fully. Like I had a student over here that was kind of confused and she really didn't want to share, but as I was kind of coaching her, she made a correction, and that's part of persevering. So she made a correction and she actually shared with the class, which was amazing. And it's really hard to get students to do that when they are wrong at the beginning and then they figure out they self-correct. So a safe environment, a lot of number talks, multiple representations, solving the problem in different ways and persevering. We've done a lot of coaching, like you heard these 2 boys doing. So one student shared something that the other didn't understand or didn't agree with, and then so he was coaching to help him. We've done a lot of accountable talk to get the kids to discuss whether they agree or disagree, things like that, and build onto each other's answers to build that deeper understanding of the concept. A lot of the talk moves, revoicing, so that everyone can kind of access each other's thinking, agree or disagree, things like that. I've done a lot with the math practices, so you heard the kids talking about persevering, making a plan, changing the plan, using precision, looking for patterns and numbers. So we've modeled that a lot and done activities like this where you have to kind of identify the aspects of the 8 math practices in class. Okay, can I take a breath for a second?
Sure.
Okay. All right, I'm ready. Okay. So after this lesson, I will probably have the students choose one of their favorite strategies or one of the most effective strategies and do some writing about it, because we have a math center where they do math writing to explain their answer in words and justify their answers. And then just continue to solve real-world multiplication problems. So that school math is similar to real-world math. So they see that connection. Okay, I'm done with that.
All right. So this next one is, talk about the standards or cluster targeted in this lesson. What did you do to make the lesson reflect the full intent of that standard or cluster?
Oh, okay. Hold on 1 second.
Sure.
Shoot. Okay. What did you do to make the understanding? All right. Okay, our standard was to multiply and divide within 1,000 in solving real-world problems. But before that, I had taught them the concept of multiplication so that they were able to apply their knowledge of multiplication in word problems in real-world situations. And I did that through number talks, all of the accountable talk moves, modeling, discussing, multiple representations of problems, things like that. Okay.
All right. Which of the core action indicators do you think this lesson best exemplified, and how did you plan for this?
Okay. So do you want me to read the core action? Like it's core action 2 is what I think. Do you want me to?
No, you don't have to really. I mean, you can say core action 2 and then kind of adapt it to how.
Solution methods. Okay. I think this lesson best exemplifies core action 2 because students were sharing multiple strategies and responding to each other's strategies so that they can deepen their understanding of multiplication. And the way that I've kind of planned for that is throughout the year, highlighting multiple strategies in different problems and sharing and discussing and encouraging students to use multiple strategies to kind of have a tool belt that they could use for applying that to different problems. Tool belt of strategies. Okay.
Okay. All right, so we're interested in how the shifts required by the CCSS are being incorporated into your classroom. Discuss how this lesson illustrates the shifts required by the CCSS.
Okay. All right. The shifts required by CCSS are focus, and I think that we've done a lot of work with the conceptual understanding of multiplication. We're really focusing on what it means and what the numbers represent and how you could solve the problem, just to develop a conceptual understanding of it, and then we move to the fluency and the application piece of it. For coherence, we started with their understanding of repeated addition. So repeated addition is very similar to multiplication. So build on that knowledge when you're multiplying. Use that to multiply at the very beginning. Let me see. All this is so similar. Is it okay? I mean, all of my all my answers are just very similar.
That's fine. And if there's something that's redundant, I mean, you can skip over.
Okay. Procedure and application. Yeah, because this is very similar to what I've already said. And for the rigor, you start with a conceptual understanding so that they have the knowledge for the procedural part of it. So conceptual and then procedural fluency, and then you go into application. Okay, next question.
All right. So how did you teach the content of this lesson prior to the CCSS? What is the same and what is different?
Oh my goodness. Prior to the Common Core standards, there was a huge emphasis on just getting the answer. What is the answer? Okay, we're moving on. No, how do you know? What strategy did you use? How do you know your answer is correct? How could you explain that in a different way? There was none of that questioning or even the students even thinking about it in a different way. It was, I got the answer, I'm done. It was a lot of drill and kill, time tests, which a lot of the kids had so much anxiety about that. It was just really surface level knowledge prior to Common Core standards. And now I feel like we're kind of digging into the conceptual understanding, like why are you doing this? What do these numbers mean? When would you apply this? And how could you apply it? So a lot of that questioning the students to get to that conceptual, deeper understanding of the concept. Let me see. Okay, can you ask that question again?
Sure. How did you teach the content of this lesson prior to the CCSS?
Oh.
And what is the same? What is different?
Okay. I think a similarity is an emphasis on knowing the facts, because they still need to know the facts. You're just kind of going about it in a different way, I feel. And starting it, building that conceptual understanding differently and expecting them to know it maybe later on in the development of the concept. So scaffolding a lot more prior to the fluency piece. And this is all stuff I've already said.
No, that's totally fine.
And I think the difference is building conceptual understanding before you go to the fluency part. So they're doing a lot of hands-on, using manipulatives, using multiple representations, so they have that really deep understanding before they memorize the facts and go into the fluency and application piece.
All So, third section here. Student engagement is crucial to the work of the CCSS. We want to understand how you ensure that all students have the opportunity to productively engage in the work of the lesson. So, how did the students handle this lesson? Did they understand the mathematics of the lesson, and how do you know?
I think that there was a high level of engagement because there's a lot of accountability. They share with a shoulder partner, but then they also have to respond to their partner's strategy or ideas, so they're actively listening. So that's the engagement piece, and I always want them to share, do I agree or disagree, and why. That's the reasoning piece of it. I think the students handled it very well. They were all able to solve the problem using multiple solutions and strategies, and they all had that deep level understanding for multiplication to be able to do that. Most of my students have, let me see, can I look on this? Okay. So as I was walking around, I was kind of making notes about the solution types, the problem types, and the way that they were solving it. Most of my students have a level 1 understanding, so they're able to make an array or groups that would represent like the 6 and the 7. Six groups, 17 in each group. Quite a few of them were using repeating the skip counting. There was only a few that were able to decompose the numbers so that they could multiply, like for example, 6 times 10 and then 6 times 7. So they're able to decompose that number in a way that was easier for them to solve. So I probably had maybe 3 or 4 students that are decomposing the number and at the level 3 of problem types.
All right. Explain how you differentiated this lesson.
Oh my gosh.
Did all students have opportunities to work on grade level content? If all students did not have this opportunity, please explain why.
Okay. Did all students have opportunity to, okay. All students had the opportunity to work with grade level content. Some of them are still really concrete, using the manipulatives to help them solve the problem. Others are able to solve it in multiple strategies, and they have a really good understanding of it. I let the kids partner share a lot, and that's part of the scaffolding where they can share and then respond to each other, and they could do some coaching. I find that when my struggling students share with a partner first, then they're more willing to share with the whole class afterwards because they feel successful. They know their answer is correct. Let me see. Which part of that didn't I answer? Oh my goodness. Okay, what actions have you taken as a teacher to make that happen? Behaviors and corruption. My students exemplified core action 3 more so than any of the others in this lesson. They were talking, they were questioning, they were responding to each other, they were engaged in each other's strategies, and they could see the thinking of others by looking at their math journal. And that's something that we've done the whole year to encourage them to discuss and just learn from each other.
Perfect. So you got the core action 3 part in there. That's good. Would you like to comment on any of the submitted student work? Was there anything that delighted or surprised you?
Yeah, the thing that surprised me the most about the lesson is that the kids weren't as willing to share as they normally are. Typically we have really great math discussions about why they agree or disagree, and they're justifying their answers, and we have these really good discussions in class about math concepts, and they were
Okie dokie. So, reflecting on the lesson, what worked particularly well and what might you do differently?
Oh, I thought I was answering this first one. Was I not answering? So I think I answered that one and the other one. So commenting on student work, is that the one we're on?
Sure.
Because I think I flip-flopped those answers before.
Okay.
So I'm commenting on a student work sample. So
Okay.
Okay. I think that the students did a very good job of representing the problem in different ways. They were using arrays, they were using counters, they were decomposing the numbers, so that they were solving the problem in different ways. So that tells me that they understand the concept of multiplication and are able to apply it in different situations.
Excellent. Were there any surprises or unexpected student behaviors or reactions?
I was surprised in the fact that the students were hesitant to share They were hesitant to share if they weren't absolutely positive that their answer was correct. Typically, we have a lot of great discussions when students, they kind of go out on a limb and they share their thinking, and then other students are able to coach them, and then we have the great discussions. But today they were pretty quiet, and they didn't want to have a wrong answer on camera, I think. And who can blame them?
All right, that is it. Thank you so much.